Okay, let's get started. Good morning, good afternoon, good evening to everyone, and welcome to Data Driven Community Virtual Meeting. A few words about Data Driven Community. If you check the community website, then you can notice we are managing two different branches of activities. Scroll down the page a little bit to see the upcoming events. On the left side of the page, you can notice the Future Data Driven Summit, an annual joint conference we are leading and running with multiple data platform user group partners. The second branch of activity are weekly meetings of the cloud data driven user group like we are having today. And you are more than welcome to contact any of the community board members. Jean Joseph is the founder and co-administrator. Ronan is the second co-admin and Anna Bikes is the third moderator. My name is Deepthi Goguri. I'm a database administrator and a data platform MVP. I'm a third co-admin of the data-driven community, and I will be hosting the session today. Together, we are here to help and serve the data platform community. During the meeting today, please feel free to use the chat and for any questions and discussions as well. You are also welcome to use the reactions. It doesn't interfere with the course of the meeting. So if you hear something you love, like, or you want to clap hands, then feel free to do so. Today, we are honored to have Steve Campbell with us. He's a co-founder of Analytics Endeavors and Microsoft MVP, and also he's a owner of Sunny BI Power BI training. Steve, can you please go ahead and share your screen and add a couple of more words about yourself?
Yes, definitely. And then do you want me to get started after that?
Yes.
Okay. Perfect. Can you see my screen okay?
You can see.
All right. So my name is Steve Campbell. As mentioned, so I am a co-founder of Analytic Endeavors. We are a consultancy that does data platform and all kind of cool things data. I'm also the owner of Sunny BI, and I do training for Microsoft. And this is, well, for Microsoft products, I should say. And this is heavily around Power BI and Microsoft Fabric. I'm also a Microsoft MVP, and I'm very active on LinkedIn. So this is definitely the place to reach me if you want to message me or have any questions about the demo. So today, and please feel free to in the chat message anything if you have any questions, definitely put it up in the chat. Today, I want to talk a bit about Git, and then we'll look at it in terms of Power BI and how we can use Power BI developer mode to enable us to do Git. So firstly, let's talk about a semantic model. So when we talk about a semantic model, and this is, the data set in Power BI, there is really two things inside of a semantic model. We have what is called the data and the metadata. So the data is a copy, and this is true for import mode. Direct query and direct, like the new one, works slightly different. But for this purpose, we're going to be talking about import mode. So the data, it's a copy of the data from the source. So we copy it into Power BI. We can't actually edit or modify this data in Power BI. We can use Power Query, which tells the engine how to use it. But after it's been imported, the data in the semantic model, we can't change it because the data there is stored. And after we've done our initial transformations, there's no way of editing it apart from changing Power Query, doing a refresh. And stored in a column store format, right by the Vertipack engine, just how it's stored and the engine name. The metadata, on the other hand, is all text-based code files. This is stored normally in Timdal, which is the new format if you're going to use Git. And it includes items such as Power Query, DAX, security, all of this kind of stuff in the code that we write. it's stored in a TIMDL file. This tells Power BI, right, where to get the data and how to aggregate it. And it's this metadata which we're looking at. This is actually just stored in its own format called TIMDL, and it is just a text file that has all this code and all these instructions. So with that, let's step back and talk about the introduction and what Git is in hopefully nice and simple language. So imagine that we have this file, and if you've ever worked with the finance team, right, in Excel and they're doing budgets, it may look something like this. What we do is generally when we're working on things, we make edits, but we don't want to save over the original file because we're worried that we may have made a mistake. So this happens a lot. And imagine that I'm doing this and I have all my colleagues who also have their own versions, and it gets very out of hand. So then the simplest option would be to use a central document. So we could use something like OneDrive or SharePoint, where we all share the same document. This is a type of version control source system, or OneDrive and SharePoint. However, Git works slightly different in the fact that we call Git being distributed. What this means is that with Git, we actually have a copy each of the master data. And then there's a main copy hosted online somewhere that we all update. So Git is distributed, and that means we all take individual copies of the code. We work on it individually, but as a system in order to keep the main copy, which is hosted online, up to date with all of our changes. So let's look a bit on how this works. Now, as I said, when we have Git, we take copies of code and we work on our own machine. So we're going to look at myself, and I'm working on a bit of code. And you can see this. This is a snippet of code and its columns in a semantic model, for example. What I do is if I want to enable Git, I can run and install Git, which is open source and free. And basically, Git just runs this little database on my local machine. And what this database is it's just saves each version of the code. So every time I save, I create, just like in the first example, lots of different saved versions. If I make some edits and some different, make some updates to my code, what happens is I save a new version into my little database, which is running on my machine, and it keeps all of the versions. So you don't see this, it does it in the background, but it keeps its versions and it makes lots of little saves into the database. And then maybe I make a third change, I delete a column and I save it again, and now it just saves the file again. What happens though is I'm not editing the file and overwriting, I'm making lots of saves and lots of different versions into my database. And this is all running on my machine. It's a small little file. Because Git uses code only, this is very easy to do. It doesn't take much space. What is really cool is that I can actually go back in time. So if I want to see what my code looked like in a separate time, I can reload old versions. So instead of, having version 1, version 2, I can actually just go back, and because Git manages this for me in the little database, I can go back and see previous versions. So Git essentially is a little database on my machine where I can save lots of different versions, and it keeps all of the versions so I can compare or roll back changes. And what we do is when we save it, we call this a commit. And commit means just to make a little save of the version of our code. So when we do commits, though, there is lots of us doing different commits. And because this is distributed, we all are working on our own individual copies of the code. And then we have the main copy of the code, and that is hosted online. And this is a central location where the code and related files are stored and managed using the Git version control. This is called a repository. And the repository basically means where is our code stored? It is the master version, right? The main copy of our code. And this is the one that we're all working on individually. So what we do is we make, after we've done working individually, we make little commits, we make little saves. And then what we need to do is, because we're working on a local machine, is save this into our repo. And this is called a merge. So I've done something on my local machine. I've made some little changes to code, and we don't have to be writing code, and we'll show that in the case of Power BI. But what we're saving is code. Then we save it into our repo, into the main copy, and that's called a merge. We're merging our changes back into the main one. So in the case of Power BI, what we can do is we can save into our Power BI developer mode. And this Power BI developer mode basically takes our PBIX file and splits it into lots of little text files. Because we only need, with Git, we need to work with code. We like to save lots of little text files, and that makes us able to use Git. And that's what Power BI developer mode is. It's a preview feature at the moment, and it's called PBIP. And you'll be able to see it if you go to Power BI's preview features. What we then need to do is we need to open an editor. And in order to use Git, we normally use VS Code, which is a free tool. And that enables us to do the initialize Git database. So after we had our PBIX, we did this changes it into text files. Then we need to open this editor, which lets us initialize Git, because we need something to run Git. We make commits locally as changes are made. So right now, we're just doing everything on our local machine. No one else is seeing any of these changes, but we're working on specific things. Then once we're happy, we merge to the remote repository, and we can say we need to check in our code. I see a question. It says, in Git, does it merge all the version from my local machine? Normally, you can publish specific items. I'll show you an example afterwards where we can actually choose what we commit. And there's lots of ways to check this before we actually update and merge. And that's one of the beauties of Git, is that there's a lot of checks, so we don't have to merge everything, and we can check what we want to do. Okay. I just want to stop and check if there's any other questions in the chat. I don't think so.
Question we have.
Okay, so the next thing I want to talk about is branching. So Git is basically that. It's just a little thing you're running on your machine. And Git is not owned by a big company. It's a free and open source system. And you can actually download and install Git and use a free tool to actually manage it on your system. It's basically a little database on your machine that you can save lots of updates, and then it allows you to merge it to some main version on the code where other people have. Now, one thing about Git is that it's meant for multiple developers to be working on the same bit of code at the same time. So we use something called branching to manage this. Normally, we have a branch called main. And what this means is that in our repository, in our repo, in the main version of the code online, we have the code and we call it main because this is the one which we know is the most up to date. It's the one that we're working on. We might say, hey, we have our Power BI model. We need our Power BI developers to go in and update some code. Maybe they need to update and add a new table into the Power BI model. And we're going to call this a feature. So we say, let's work on this. But we don't want to work on the main copy of the code because we want to test it before end users see it. So we create a new branch. And each of these circles, you can imagine, is just a copy of the code. So in the main, we actually take a new copy and we do something we call open a feature branch. And there's websites and systems which help do this for you, GitHub being one of them. And so we're going to say we open a new branch. What a branch is, it's just a copy of the code that we're doing something specific. And this feature branch is adding that new table. So we say we're going to add the new table into the Power BI semantic model. So we're going to take a copy to work, and the developers are going to work and test and add the new table, add all the DAX. However, what happens is someone's noticed that there's an error in one of the measures. And this is on the main copy of the code, and we realize that some of our numbers are wrong. So we need to change and update specific measure, right? It's called a hotfix because this is something that's broken and our CEO is seeing the wrong numbers. So what we do is we take another copy of the code to fix this measure. You will notice that we take a copy of the main. So while this feature branch, those people are actually working on that and they're adding this table, we're taking a copy. That's not what they're working on. It's a copy of the main one that end users are seeing to fix a very important issue. And so what happens is that the team who are fixing the issue, they fix the issue and they basically merge their changes back to the main branch. So they've gone on their copy, they fixed it and they're happy. It's very time sensitive. And they say, let's put our changes back to the main. And so they can see their hotfix and they can actually until they're happy that they fixed the issue. However, these guys over here, they're still working on their feature branch. They're still adding their table. You can see their copy of the code doesn't have the fix that the hotfix branch has. However, when they're happy, what they can do is that they can add their changes back into the main copy of the branch. So you'll see they're adding their changes and the copy that they're adding to is a different copy than they started working on. This will work because the hotfix branch fixed a specific measure. The feature branch went and added a table, so it's a different part of the code. As long as they're not updating the same part of the code, they can both work on this independently. And it doesn't matter that both their versions are a bit different, because when we merge, it only changes the lines of code that we updated. It doesn't replace the whole code. So we can work on separate things and separate parts of the code simultaneously. Of course, if we both try to update the same line of code and we both worked on the same table and made different changes, this would be a conflict. And what it would do, Git would be smart enough to realize that we both tried to do things to the same line of code, and it would ask you to manually resolve this. So let's look at this through an example. This is our main branch. In our main branch, we have a very, very simple piece of code. It has 3 lines in it. And Git, it works by using line numbers of the code. So this is hello world by, and you can see there's 3 lines. And this kind of knows how we're working on each line of code. What Power BI developer mode, that new mode, which is enables Git, is it rewrote the internal files to use a structure which has, firstly, it has lots of small files, and then it has lots of lines. And this is more likely to enable us to work on different bits simultaneously. What we're going to say is we're going to open a new branch and a new feature branch because we want our developers to work on these pieces of code. It's very simple, but we're going to open a branch. So in the repository, in the, this is online, this is the central one, we make a copy of this code. We call this to check out the code. So now we have the new branch. What happens is we are now going to work on this on our local machine. So we have the main branch, which is in the repository online. And we call this the remote branch. This is the copy of the main branch. So it's the copy of the main code, which is still stored in the online repository. As I said, Git is distributed and we can work locally. So I actually make another copy. So the copy I'm working on is really a copy of the main code. And that's local on my machine because now I have it locally and I want to make edits. I will just say this, we're not going to go into this part, but it's important if you use Git because you will see this. You actually have an extra save when you do that little save and you do the commit and when you save it to that little database working on your machine. What happens is you're working, it's called the working directory on the file. You have a staging area. And this is something where you can actually choose if you want to commit everything that you've done or if you just want to make certain stages and just do certain changes. And then it's your local repository. So it's like the staging is just a check between you working and saving it. You can skip it if you want, but you will see it if you work Git and we'll see it later. So it's important to mention. And if you want to look more into it, when you start using Git, you'll be able to understand how to use it. But there is this extra step before you do these commits and saves. So I have my copy on my local machine, which is a copy of the branch. What I do is I'm going to make my changes. So what I've done is I've changed the second line from world to planet. However, Git is really good at multiple users. And the idea is that we can have multiple developers working on the same time. So over here, we have Dave. Dave is also working on the code. And he is also working at the same time. And he knows what I'm doing and I know what he's doing. And he has now changed line 1. So he wrote, hey. Because we're both working locally, we can see that Dave's copy and my copy are out of sync. However, so what Dave does is he says, I'm going to push my changes. And what that means is from his local one, he can push his changes into the main branch. This updates, or into the feature branch. This updates that feature branch, the remote repository online, with his changes. You can see he's only changed line 1, so it's only going to overwrite line 1. I am still working on mine, and I know Dave's working on his, and I think he's told me that he's made some changes. So I can create a pull, and I can pull action. So I want to check the remote branch to see if there's any updates, and I can pull those updates into my version. The only difference from the branch to my version was lines 1 and 2. I had changed line 2, Dave had changed line 1. Because we were working on different lines, I can, without an issue, pull his changes and merge them into my version. Now I have the update version, and I can push this back into the main version of the code. Usually, you would do a push and a pull at the same time, and you would do this often. So you wouldn't just do one, you wouldn't just upload your changes or pull someone else's changes. You would sync, it's called, and you push your changes and pull new changes. So you can do both actions at the same time. And again, we need to communicate and make sure we're not working on the same thing. If we both try to change the same line, it would have an error, and we would need to manually resolve it to say which version we want to keep. And so we get our changes from a pull, and we can also do a push. And there's a repository online, and we've changed the code. What we now want to do is we say, we're happy that we've updated this branch. The branch should be fairly small in size and add specific things. Once you are done with them, you open many branches and then you close them and delete them. So they should have purpose. So I've done the purpose and I say, let's get our code back into the main one. Let's pull our code back into the main branch. So I can just merge it with the main one. However, this main code is live, right? This is what the end users, and it's going to go out to the end users. So what we can do is add yet another step here. This is called a pull request because we're pulling our changes into the main one. What a pull request does, though, is instead of just allowing us to add our branch directly into the main code, we have a review process. And this is generally done by other people who weren't working on the branch, who weren't the developers making the change. We will have a look later, but you can see on the code exactly what was changed. One big thing about Git, and we'll see this too, is that every step people are making comments about what they changed, and it's tied to your email and it says who did what. So they're able to read all the comments. They're able to look at the code, and it's just another step to make sure that we don't get errors further upstream. So lots of steps and lots of commenting, lots of describing what we're doing so that we know we're doing something well, and it's less likely for it to be wrong. So they also include comments. Every time you do commits, you can comment. Pretty much every step of the way you make a comment. And then when you open a pull request, you can say all the changes you made. The team can go look at it and they can approve it or deny it. And maybe they've spotted a mistake you didn't see. And me and Dave, we didn't see the mistake. And this pull request is from pulling one branch back into another branch. Usually the feature branch, for example, in this case, back into the main branch. Okay, I'll just pause in case there's any questions. Check the chat. I think we're good.
Yeah.
So this is Git. Perfect. Thank you. This is Git. I want to speak about GitHub and Azure DevOps. Just quickly, so we know the terminology if it's new to you. Git is a distributed version control system, right, for tracking changes and collaboration on code. We've just seen this. Git itself is an open source project. So it's not owned by a big company, it's open source. Anyone can use it for free. GitHub is a web-based platform for hosting Git repositories, right? So while Git we run on our local machine and we use an editor, we need somewhere to store the main copy of our code and to make branches. We need a tool that can actually create these branches. It can do the pull requests, basically manage all our code and store our code, because obviously we need somewhere to storage. Storage isn't free. So GitHub is one of those tools and a product that does that. This is owned by Microsoft, actually. They bought it a few years ago. Azure DevOps is another tool. What I would say about Azure DevOps is that it's actually an end-to-end software development. So it includes Git, it's a big part of it, and the repositories. It also does things like planning and basically project management. So it's a tool that doesn't just do Git, Azure DevOps, and it does a lot more. Personally, I'm really fond of Azure DevOps. I think it's quite a good tool, and I actually use Azure DevOps most of the time. This is also owned by Microsoft, so they sort of bought their way to a monopoly on a lot of the Git stuff. There are other tools out there, right? So you don't have to use GitHub or Azure DevOps. These are by far the most common tools. When we're doing these merges, as I mentioned earlier, if we have two versions, and this could be when we're committing stuff or when we're merging stuff, we can have something called a diff compare. Diff compares show you side-by-side copies of the code. It's the code that you're working on, as well as the code that you're merging into or the one that you're changing. On this, you will see a number of things. You will see on the, I might zoom in here. I won't zoom in. On the right, we have red and green lines. These are all parts of the code that have been changed. So you can see each part of the code that's been changed. Red means something's been deleted, while green means something's been added. So in this example, just from the code I can see this part of the code has been deleted. This is, if I read it and I understand, this is actually a column. So the one that I worked on, we've deleted a column. Then on the bottom bit, we can see this is a measure. And I can see that because there's this expression, I can see DAX. And so I know I deleted this measure and it was called old price calc. I've also added a new measure, and this measure is called new price calc. So by reading the code, I can see exactly what's changed. Obviously, you need to understand the code files, and Git manages all types of code. So it depends on what code you're checking in. The whole point of Timdal, which is the new format, is that it's meant to be much easier to read. So there was an old file format called Timdal, and it was very difficult to understand, and it would just be a lot of JSON that you couldn't really understand what's happening. This new format is much, much easier, and it really is better for people. And this is for people, for example, when you're a developer and you can save and you make your commits and you want to check what you've done. It can also be good in case you've accidentally, for example, deleted a table that you didn't realize. And you can check when people are doing the pull requests. And that's when you're merging your branch back into the main copy. And that's someone like a manager or someone's checking your code. They can use this to look and see and understand what's happened. So this is a diff compare. We'll show you how your version of the code differs from the main version before you can merge the code together. All right. Now we will switch over and start talking about how we use this specifically with Power BI. What we have, and is there a tech issue in the?
Steve, we are not able to hear you properly. There is a disturbance in between. Maybe you can turn off your camera. I think that should be good. And see, we can see if we are hearing properly.
Okay. Is this any better?
Yes.
Okay. Let me know. Just message in the chat if it happens again.
Sure. Thank you.
So using Git in Power BI, what we do is we can open Power BI Desktop, a PBIX file. We will then save this PBIX file into something called a PBIP file, so we can change the format. What this does is it splits this out into lots of small text files. And it actually splits this out into multiple files, multiple folders. Git is much better with small files because there's less chance you're working on the same file, and it's much easier to know that we're not updating the same code. We then need something to read the folder. This is usually Visual Studio Code. It's one of the best. It can be many things, but we're going to use VS Code because it's very efficient. What we need to do then is we need to actually sync our code up to Azure DevOps we'll use in this example, but this is to the repository, the remote repository where we're working and the online one. So the Visual Studio Code is the bit that manages Git in this example. It can read it, it can save it to your little local database, and it can sync up to the main copy. And that here, for example, when we make changes, we can use diff compares to see things that have changed. We can push our code up into Azure DevOps. And then what happens is what's really cool in Power BI Fabric workspaces is that we can sync our Fabric workspace directly to Azure DevOps. What this means is that we no longer have to publish the PBIX file, and we can do everything within Git. All right, let us have a quick demo of how this works. So the first thing we're going to do is we're going to save this Power BI desktop into the correct format. We're going to go through the demo in the slides, and then we're going to go through it in the actual demo. We'll save it into the correct format. We'll then open an editor like Visual Studio Code. We're going to read all of our data in Visual Studio Code. We'll initialize that little Git database. We'll make some changes and save things locally. Then we'll use our Visual Studio Code to sync up to Azure DevOps, and then we will publish our code into Azure DevOps. From here, we'll sync this to Fabric, and we can see it live in Fabric. So we're going to go through, and I'm just going to go through again. The first thing I want to do is I want to open up a Power. So I have a nice Power BI file. If I go to File, I can go into my options and settings here. In options, currently, open up, it is a, here you go, it is a preview feature. So you see here, Power BI project, Tyndall feature, and this is Power BI report format, which is part of the Git. So we turn this on. Now that I've turned it on, I can go File, Save As. I'm going to go to my new folder I just made today, and you can see here that I can save as. Normally we save as a PBIX. I'm going to save this as a PBIP file and click Save. And what I've done now is that I've opened it up and I've saved it into this PBIP file, which is going to split it up into multiple folders. If I see now, I can see this has some items. It has a report folder, a semantic model folder. This one is just a way for you to reopen the Power BI file, because now we've saved it and split it up. We want to open the Power BI file if we close it down. So this is just a shortcut to open it. You'll see it also adds something called a git ignore. Git ignore is really just a list of items that you might not want to add to Git. So you may have some file or something locally you might want to change, but you don't want to check this in and you don't want to merge this file ever. So this is just a way of adding things to this list, and it says Git will ignore it. So well named. Now let's open an editor, Visual Studio Code, and read the data. So I'm going to open VS Code here. And let me open a folder. And I'm going to open my new folder, Git demo. So this is in Visual Studio. I've just opened the folder and I can see the same thing in my folder as I can in my Visual Studio. For example, I can open my report folder and you can see here there's a different folder and you get lots of subfolders. So in my pages, I pick a page name and there's a file for each of my JSON files for my visuals, for example. If I go to my semantic model, I can see each table has its own text folder. And I can say, this is the information about my table. So now I've just read it. Now what I need to do is I need to initialize my Git database. So this is starting Git using my Visual Studio Code. What I can do here is I can click to the source control tab and say initialize repository. Now what this has done is it's made a hidden folder called .git. This is just the little database that I'm saving to. Please never open this and never mess around with this folder because the stuff inside it is not meant for you to edit. It's meant for the service and the Git to edit. So this is not for changing ourselves. But I've initialized this repository. So I've made a database. Now I need to make saves into it. You'll see here, I can commit. I want to make messages every time I make a save. These are all the files that I'm going to commit. So these are all the files in my report. And these are all the files that I need to save initially. I'm going to call this the initial commit. And then I'm going to commit it. And again, committing is just saving. This is now saying, we're not staging, so we're not using that intermediary staging point. Do you just want to commit them directly and skip this, basically? I've said yes. So now I've saved all of my files into Git locally. What I can do now is I can go to my report. And Git is very cool with Power BI Project. Let's move this file and move this item. And maybe we can change the color of sales amount. So I've made a couple of changes. If I go over to Git, so I need to save save my changes. So I made a couple of changes and I've saved them. If I go to Git, you'll see here that now it's red that I've made some changes. And if I click on it, you can see here that I've actually added a new color to one of my visuals. And here you can see I've made deleted the X and Y and added new X and Y. And that's when I moved the visuals. So I can now click commit, and I should give it a message. That's really bad of me. But yep, here you go. It's yelling at me. But I could give this changes. Let's just call that. And I can commit this with changes. So I've now made my changes in my local database. I need to go to Azure DevOps and sync this up to somewhere like Azure DevOps, or it could be GitHub. So what I'm going to do is I'm going to switch over to my new Azure DevOps. This is Azure DevOps. If you're not familiar with it, it's not too important, but you can see here on the left, we have something called repos. So this is the repository, a central location. It's saying here this is empty, right? Because this is brand new. I just created it today. So what I'm going to do, I'm just going to copy this URL and I'm going to go to my Visual Studio. On my settings, I can just go to the remote and say add remote. So this is now just syncing my Azure, my Visual Studio up with my repo so that we know where to, this Visual Studio knows where to send the code. I'm going to add the URL and it's just going to make me give it a name. And now this is saying we've synced up and now we're joined. And I'm going to publish this now. So every time I've been committing before, it's been saving on my local machine. I'm now going to publish it. And the publish is now pushing my changes into Azure DevOps. We can see here and give it a refresh. We will see now that all of my files have been copied onto the online one. I'm now going to go to Fabric. I'm going to create a new workspace. And let me back it by a trial capacity. And so now I have a new workspace. Under workspace settings, I have an option for Git integration. I'm going to choose my Azure DevOps and connect. And Git has things called organizations and projects. And these are basically just, you can think of them like folders, example, and just ways of organizing your projects. So you can see which repository I want, and you can also choose which branch. Normally, we always sync the main branch because that's what it's for. It's the main one that goes to our users. I will now connect and sync. And so what I'm doing in my slideshow is I am adding this step here where I connect to my Fabric workspace and sync it up with my Azure DevOps. You'll see here, it might take a second to sync. But those items are now appear within my Fabric workspace. And again, I didn't publish this. It's going via Azure DevOps. If I go to my sales, though, for example, you'll notice that nothing has any data. When we do Git, it does the metadata only. So it's not syncing the data. We're not getting the data as well. So I need to perform a refresh on my semantic model. If I refresh my semantic model and it just uses public available data sets and I've already set up connections, now when I open my sales report, I'll see the data because I've made a refresh. What I can do is say, maybe I don't like this visual, and I'm going to change this. So I've gone to Power BI Desktop. I'm going to make some more changes. I'm going to save my changes. I can go to my Visual Studio, and it can see I've deleted this report, this visual, and I've changed this visual. I moved the X value only. I'm going to make some change too. When you normally do this, you will make very descriptive comments because this is what people can check and they can look through so you know exactly what you've done. It's going to ask them on a stage. I'm skipping that, right? And now I can sync my changes. So this is doing, you see this? The sync is pushing and pulling. So it's going to see if there's any changes made by anyone else, which there won't be because I'm the only one here. But it's also going to push my changes up into that branch. So this is going to Azure DevOps. And you can see I'm doing here, syncing my code back up to Azure DevOps. If I go to my Visual Studio Code, it looks like it's done. I can now go back to my workspace. And you can see here that it's saying I have an update required, right? It knows something's changed in the report file. I can click here on source control, and I can say I want to sync my Power BI workspace with the Azure DevOps repository, and it's going to update. So now I'm updating from Git. Of course, I was a little lazy here. Usually we did something, we'll go through that branching process. Because it's just me, and for the sake of time, I didn't show the whole process. But normally what we would do is we would take a branch, update the branch, do a pull request into main, then we would see the changes. But I wanted to show them in real time. I go back to my model, my report here, and I can see those changes I made in Power BI desktop. So this is really, really cool because it means I don't need to use that published version. I have all of these checks that I'm doing every single time. So I have lots of different ways in order to make checks before I actually publish my report, and everything's tracked with lots of comments. Of course, what I would do normally is I would make a new branch, and this is what I said, I skipped this in the interest of time. I would check out locally, make the edits, and then I would merge to my remote branch, and then before the pull request back into the main branch. And this would be that process to make doubly sure that there's extra steps. I'm doing edits and copies of copies so that I'm not updating anything that everyone's looking at. I'm making sure that this is done very securely. I have a question. Do we need to manually update, and is there any way reports get automatically updated with changes in Power BI? I would say this is still in preview and it's rapidly changing, but there are some APIs and stuff in order to automate this, yes. Generally, though, the manual checks are good because the whole point of this and the approach is actually good by default to have these checks so that we can still check things and we're not just pushing code that might have an error.
We couldn't hear you well. It's not an issue of broadcast. It's not the camera, but from time to time we are losing you for several seconds.
Oh.
So please answer again. And this is the third time that it's happened.
Okay. What I can do is I can definitely write in the chat maybe an answer to the questions if that's better as well.
Just repeat yourself.
Okay.
Because it's
Sure.
But from time to time we have a few seconds that the voice is that we are losing your voice.
Okay, strange. Sorry about that. The question was, do we need to manually update, and is there a way reporting get automatically updated? The answer is there are ways to automate a lot of the updates. However, the manual checks are very good because it gives us manual checks where we check the code, we double check everything time to time. So it's a good practice to leave in the manual checks, but you can automate a lot of this in the settings of the respective tools. And then we've said, if after this sync with DevOps, can we still publish directly? We don't want to. I would suggest you either have one workspace, which is all Git, or where you publish, because if you try and publish directly, it will mess it up and you'll probably get a copy of the file, but then your versions will be out of sync. So if you're going to do Git, you will not publish, do not publish it. Don't try and publish. Same thing occurs if someone directly modifies the report in the service. You can. That's a good question. So if I edit this, for example, I change this, and I save. You see here, I actually have changes. So I can actually go the other way and commit from the service. please don't do this. It's not a very good practice, and you don't get all the good workflow. It's a bit of an anti-pattern. I would recommend not to do this. Is there any way of doing that in Power BI report server? I do not know, to be honest. I've never tried. I don't think so. This is a preview feature in Fabric. I would guess not. Apologies, I don't know off the top of my head. I doubt it. You'll probably have to Google that one. Perfect. Oh, and someone yeah, that comes to the end of the session and the end of the demonstrations. Please connect to me on LinkedIn, and if you have any questions as well, I can definitely add there. So any more questions? I'll be around for a few more minutes to answer.
Thank you so much, Steve. That's a really great session. Actually, I learned a lot. I'm a beginner to GitHub and stuff, so this is really great. Thank you so much for presenting for us. And yeah, if you have any questions, Steve will be here for a couple of more minutes. And
thank you for inviting me. Yeah,
of course, we are honored to have you.
Let me just add a tiny point, if I may, and remind you about the next meeting. So I just want to mention for the introduction that we have another phrase that we need to remember. It's called fork. This is very important if you want, for example, to help someone else to edit his project. I will show my screen very fast. If you have questions, please use the chat. I'm just using the spare time for this. So let me show you an example, and I will also show you Steve Campbell LinkedIn page. Someone asked about it. So very fast. Okay, can you see my screen?
Yes.
Perfect. Okay, so what is fork in very short? It's simply like a copy of the entire project to yourself. It's not like a branch which is under the main project. This means that you are creating a copy of the project and you are the owner of the copy. Why do you need it? Let's think, for example, about our cloud data-driven new project that we created. It's relevant to Steve. We want Steve to give us all the information, all the session materials that you want to share with you. So we created a new repository. And now, if Steve wants to actually edit this, he is not owner, he is not member in this project. So what he can do, he can fork. When you fork, you create a separate project that you own. Once you do the fork, you can edit it because it's yours. You can create a totally different project. But in our case, for example, he can edit what we have, add his materials, and then he can pull requests. And this is not exactly, but almost the same way that you are doing with a branch inside the project. He will send a pull request, and then the owner of the main project, the original project, will choose if you want to get those changes. This is the same way if you want, for example, to edit Microsoft document. If you go to Microsoft document, it is open for you to edit, but once you will click edit, you cannot actually edit the original project. In order to edit it, you need to create a fork, and then you do a pull request. So this is one more phrase that you need to remember, fork. And I want to use this opportunity to remind you, next week we have another meeting, like any week. So don't forget to register. And Defty already added the link in the chat. And don't forget to register to the annual meeting of the user groups of data platform. It's called the Future Data Driven Summit. And this year will be the 5th time that we are running it. I see that we have questions, and I will let Defty take the control again.
Steve,
Yep.
I think we have one more question over here. Can you please
Yes.
be more specific about the issues that I may face if someone edits the reports online? I know I won't be able to avoid it.
It can work if they can commit still from online, and they can actually commit directly from the service into Azure DevOps or GitHub. So it is possible. I think it's a bad practice myself, because I think I would say the service should be just for creating, sort of viewing the report. And now you're having a lot of places. To be honest, that's my view. And there's probably some people who would disagree with me. So as long as they're still committing and syncing their code and making sure that any change that they make is updated in the master repo, to be honest, it's okay. I just don't like it myself because I find it difficult to manage and I get confused. But if it is something that your users will do, then it is okay, as long as they know to commit to write messages and to check in their code. You're welcome. Thank you.
Awesome. I hope, I hope we are on time here. And yeah, once again, Steve, this is really great. The screenshot of it. Oh, Hassan, I didn't take the screenshot of the exact slide that you're talking about. Okay, you took it. Oh, okay. It's completely okay if Steve is okay.
Yes. For this, please share away. Anything you want, feel free to share. I would love to people to post on LinkedIn, and love to follow up if anyone has any questions. So yes, please.
A lot of thank yous and appreciation, Steve. Thank you so much once again, and thank you so much everyone for joining today. And we will see you next week for our upcoming session. Do not forget to register. I posted the link in the chat window at the beginning. So yeah, see you all next week.
Thank you very much.
Thank you. Bye.